I'm here to talk today. I'm here to introduce a project I've been working on for just a little while with my amazing partner in crime, Quincy, over there. And it's called Plank, and it's an optimization platform. It's a platform. It runs in the web. It's built on Meteor, and it'll take a little bit, maybe 5 minutes to actually explain a little bit of the background story, why we built this, what it does. So the idea is, let me maybe pull over the.
If you're more comfortable on this side, totally go.
Current homepage. Okay. So the idea behind this platform is that we're doing mathematical optimization. And so if you've ever taken courses in computer science or supply chain management or maybe industrial engineering, then you may have heard of things like linear programming, maybe integer programming, maybe logic programming, maybe even constraint programming. Maybe a little show of hands. Does it ring any bells? Like 2 people. Okay. So for those of you who have never heard of this kind of thing, the idea essentially is that instead of telling the computer how you want to solve the problem, you tell the computer what you want the solution to look like. And the computer then goes, there's some solver algorithm, then goes and searches through all of the possible value variable assignments, all the imaginable assignments, and it's going to pick out the one that actually fulfills your criteria. And if you're searching for the best one, if you're optimizing, it'll keep searching to find you the best possible solution. And if that still sounds a little abstract, so the textbook example is a Sudoku puzzle, which hopefully you know what that is. So it's this 9x9 grid with where you're filling in the digits. That's something that's very easy to model as a constraint program, for example. So you would just tell your solver that in every row and every column, that way and this way, all of the numbers would have to be different, and in every one of the subsquares, the numbers would have to be different. And you hit solve, and the solver then goes and looks through all of the numbers and figures out what's a solution that works and that fulfills these criteria. So that's constraint programming, and then there's a lot of different there's a lot of different solvers that deal with this kind of thing. And some solvers really just search, brute force through the solutions, hopefully in an intelligent way, not looking for solutions that you know up front aren't going to work. Some solvers work more on a mathematical basis, so you really have some sort of equation and you're trying to find the best solution. So, if you're coming at it from the optimization angle, if you've ever used GoalSolve or GoalSeek in Excel, that's actually optimization, right? Because you're minimizing the difference between what you're looking for and the value in that cell. So this is the kind of stuff we've been doing. And so even though these algorithms have been around for a long time, and most everyone who's studying computer science, between now and maybe 40 years ago had to learn how to do this, it's actually used in the real world very little. So the only places where this kind of stuff is used right now is in big corporations, oil and gas companies, big logistics firms that are using it to optimize their operations. And that is partly because if you're looking for an industrial strength solver, like an algorithm that can actually deal with huge problems and solve them quickly, those are super expensive. So they're easily $5,000, $10,000, $15,000 per seat. The other reason is that modeling these problems mathematically, if you have a more complex problem, scheduling, planning, whatever you're doing, it's a little bit more of an art than a science, really. It takes some experience. And not only that, the other part is that these solvers are really just available as C++ code. So you have to be a coder and you have to know how to translate these libraries into something that an end user can actually deal with. Does that make sense? Any questions so far? Okay, so now the reason we built this thing is that in the last couple of years, we've seen out of the research community come a bunch of solvers that are A, open source, and B, really good. And on the UX side, we now have these awesome web technologies like Meteor and React that make it really easy to build these platforms, these frameworks very quickly. And we figured, why not take these new solvers that are out there that nobody's using because it's still way too complicated, and build a platform around it so that it's really easy to build apps for clients that need this kind of stuff really quickly. One of these solvers, for example, is Google OR. So Google has this suite of OR. So OR stands for Operations Research, which is the name of this field of research. So if you look at Google OR, they have one suite of really cool, really powerful solvers that are out there nowadays. So that's one example of the ones that we're using in the background. Yeah, so that's the background story. Any questions so far before I show you how it works? Okay. Actually really warm. So let's go back to the screen. So I'm going to show you maybe one or two of the problems we've been solving. So the first one that we solved was for a nonprofit here in Toronto. They're called Pathways to Education. So if you haven't heard of them, they're these organizations. They're all over the country now. In their downtown Toronto branch, they have around 120 tutors. And so they have these volunteer tutors that come to their branches. They're normally community health centers. So they're located in low-income neighborhoods. And they provide tutoring sessions for high school kids after school. And so what happens in these locations is that they get these, so as I said, in downtown Toronto, they have about 120 volunteer tutors, and each one of those tutors has a bunch of different availabilities, right? They can, maybe make it on Monday, on Thursday, on Friday. They have different subjects they can teach. Then they maybe have a preference, I only want to teach older kids, I only want to teach the juniors, and so on. And so what happens every semester is that they spend about 2 weeks trying to come up with a schedule that fits every one of these tutors into one of the 8 tutoring sessions that happen every week. So they have, in this location, they have 4 sessions every week, 2 rooms. And so now you're trying to assign tutors to these rooms so that A, as many of their preferences are actually fulfilled, and B, they're trying to balance the coverage of subjects that tutors can teach across the rooms and across the days as well as possible. And normally that takes them about 2 weeks to do by hand. So they start with this big pile of paper, and then they try and just sort, really just like a giant Sudoku, trying to figure out a schedule that kind of works for everyone. And so we said, okay, this can be done so much easier. So this is the platform we built. And so at this point, whatever you see, especially if you're maybe relatively new to Meteor, if there's anything you see that you think, oh, how did you guys do this? How did, just shout out and I'll answer your questions. So this is the app we made for them. So it's relatively easy. So you paste in the list of all the tutors you have from Excel. You enter your sessions. You enter the subjects that you're teaching, you enter the rooms, and then from these sets is generated, for example, the availability table, so you can check off which tutor can teach on which day, okay, and similarly, which tutor can teach which of the subjects, and then you have a bunch of other tables. So for example, some of the tutors may prefer to only teach seniors, so that's one of the things that they wanted. You can weigh subjects differently. So math is way more important, that the math tutors are balanced out across the days compared to, say, the French tutors. And you can decide that some of the subjects may be only taught in the junior room or the senior room on a given day. So you fill in all of this information, and you hit solve. And now what happens is that a solver now runs on the server and actually looks through these millions of combinations, and every time it finds a better combination than the previous one it found, that number goes up. So now it's like 6 solutions, 7 solutions found, You have a timer that just froze on me, wonderful. And that 51 you see down there, that objective value, is what the constraint programming people call it. That in this case is a measure of how far we're away from our target, which in this case is how far we're away from a perfectly balanced allocation of tutors to days. So this might take a little longer to actually go towards 0, but we can just accept it now because we're efficient. And so now this spits out, and I'm going to first show you the actual raw output. This spits out a table showing you exactly, okay, this person should be assigned to the junior room on Monday. And so on. And then they asked us, okay, actually this doesn't look very nice. We would like to have a little bit more of an interactive look at this. Can you make us an interactive view that represents this assignment table as an actual schedule? So something we can print off, maybe we can modify so Carol actually can't make it on Tuesday, that we can delete her. We can schedule her somewhere else. And we'll get an overview right away. I mean, this is something you could obviously make in a spreadsheet as well, but this now is directly hooked into their assignment table that was generated within just a couple of seconds, which normally takes them 2 weeks. Questions so far? Thanks.
The solver, it's not running in Node or JavaScript, is it running?
No, so the solvers are C++ code, and those are so they're running on the server. The way it works, I can show you the way it works. So there's a package called Meteor Job and Meteor Job Collection, and they're a queuing system. So what happens is that in the browser, as soon as you click solve, it's a really awesome package. You should check it out. A job is created on that database, and then you have a worker on the server, which is a completely separate Node script. It's just like one JavaScript file that is monitoring that database or that particular collection via DLP. And every time a new job is placed in that collection, it grabs it. So that holds all the information, all the input data, and it then calls that, it spawns a new process, like actually a Unix executable process with that data. And the output data is piped back again to that worker script. And then that's written to the database, and that's how it, does that make sense?
Yeah, absolutely. It's called Meteor Job, right?
Meteor Job, and then there's Meteor Job. So the guy running it on GitHub is his handle is VSI. I think his name is Vaughn Iverson. Very nice dude. Very responsive.
Did you say it doesn't have access to the Meteor environment? It's just a Node script that's running the job? Did I hear you correctly?
I can pull it up. So yeah, that's correct. And that is the reason we did it that way. Eventually, okay, how do I do this? The reason we did it that way is because eventually we would probably like to have this run on another server, maybe Amazon or Google Compute Engine or something. And so it's nice to have a separate process or multiple of them that just pull their.
But you don't want it to have the rest of your app in it, so you don't want to have access to your same function library.
It doesn't really need to. It doesn't really need to. So this job collection really does everything you need for you. Where did I put it?
That's okay, I'll check it.
No, I found it. So it really is a separate, well, you probably can't see it anyway. Okay, so it's really just a separate script here. So it's one file, as you can see. And all you do in the beginning is you pull in this raw DDP package from NPM. And then there's DDP login, which actually gives you access to the database on whichever host you need it, and the job collection.
How do you call a C library?
Can you see it at all? Or is this too dark? Let me try to open it in a different editor. That's better. So up here, can I make it bigger? I'm gonna make this bigger. Can you see it from back there? Can you read this? Okay. So you import spawn, okay, which comes from the node library child underscore process. And then you can use this spawn function. You have to just find it somewhere. You can use the spawn function essentially in the same way as you would just call any other program in your terminal. And that gives you back the handle, which is the process ID essentially. And then from there you can create callbacks that give you access to the standard input and output. Yeah, here, sorry. So you call it like that. So you just go spawn. Solver exec name right now is just a variable that holds that actual invocation. And then you pass it the arguments, environment variables if you need to, the current working directory if you need to, and then you can just have these callbacks on the standard input output.
Thank you.
Yeah, makes sense.
So what does the app actually do in essence? You just put together a bunch of disparate pieces of data and connect them in some meaningful way? Like how do you access the input tables?
Yes, so okay, so let me show you. The real benefit of having this kind of platform is that we can build these apps very quickly. And the way that works is that you have this backend. And right now, this is really a little bit too complicated for the layperson to understand. Hopefully, it'll be easier in the future. But you set up these tables and these sets. Okay, so you can see here tutor session subjects rooms, and then for every table, what are the dimensions, what are the data types, and so on, whether it's an input table, an output table. And then you can go and you can set up the constraints, and they kind of look like this. So this is a modeling language. This is another one of these open source things that very recently came out of 2 universities in Australia. It's called MiniZing, and it's kind of like Excel. Like it's not very hard to understand. And then you can set up the constraints like that. You just write constraint. For example, for all tutors, for all IN tutors are in rooms, the sum of the sessions of your assignment has to be at least equal to the room requirement. So you set it up like that, and that stuff. So all of those constraints and the data all get pulled together, compiled into this low-level constraint language, and then passed to the solver.
So the solver is typing that language as input.
Yeah, that's right.
It's aware of the language it's constructed.
I have a question. So is this general? Like could somebody else with a totally different constraint solving problem like use the app, or is each app built specifically for a specific client?
So that's a very good question. So right now it's built specifically for every client, but it's very quickly. It happens very quickly. So that scheduling thing that we built here, that we can essentially do in an afternoon, right? And normally these things are built either in C++ from scratch, or a lot of people use stuff like VBA. To build something equivalent, it takes you like 2 or 3 weeks at least to do it robustly, and we can do it in an afternoon. And so another example, just to show you another example, we were doing manufacturing stuff. So you can imagine you have a factory and you have a whole bunch of machines and you have a whole bunch of products and a whole bunch of orders, and different orders have different products, and every product goes through the machine in a different order and at different speeds. And then you have batch machines and so on. And you can imagine with a lot of orders, it gets very complicated very quickly, and you wouldn't believe how many people still schedule this kind of stuff by hand or in Excel, even though obviously there is expensive enterprise software to do that stuff for you. But that's just another application. And so it's just a different constraints, a different set of constraints that you write up in the beginning, and then in this case you would get a bunch of start times and durations for the different jobs, and then you can display that as a Gantt chart or whatever you like.
Cool. Sorry, I'm new to Meteor. So why Meteor? Why did you choose Meteor? Like what does Meteor give you as one of other languages or any other kind of frameworks or anything?
So Meteor is really easy to get started with on a new project. I found particular in comparison to starting out with Node, just vanilla Node and say Express, for example. And for me, it's mostly because obviously you have the whole DDP thing that takes care of the whole database communication for you. It does everything automatically, reactively, in real time. It's awesome. So you don't end up writing. You don't really end up writing an API. So you have no REST endpoints or anything that you have to. No AJAX requests. Nothing. That all happens in the background. And the other thing I find really useful personally is that the account system is all set up for you. So you don't have to worry about authentication, passwords, all that garbage is all taken care of for you. So those are the main selling points for me. And obviously that's kind of leads into my little React Webpack thing that I was going to show you. It's actually taking much longer than I expected. But when did we start? Quarter two, maybe? Okay, so any more questions? No? Okay, cool. All right, so a little bit about Webpack and React. So how many of you here were here for this gentleman's talk on React 2 months ago? Just a few. Okay, awesome. So I actually wasn't aware at all that Blaze is being deprecated, abandoned.
Oh yeah, so and I shouldn't imply. You should read it because I think if I made it sound like he's being abandoned, I don't think that's the case. It's like
no longer developed.
I think that there will be like maybe the same APIs, but the underlying thing will be powered by React or something. Like it wasn't clear.
Yeah.
It wasn't clear, but I think what they're just trying to say is that they don't want to be like reinventing the wheel, and they want to be just using what is actually the most popular thing anyway.
Mm-hmm.
And so you can still, I think you will still be able to like use the same. In fact, even right now, there's like already packages that let you something called sideburns. Sideburns, thanks. That's it. So I was thinking mustaches, but that's not right. That lets you use React, but code with Blaze like API. So like you could actually replace. You could take a Blaze like an app that's built with Blaze and like have it be using React like without you being able to even you don't have to write JSX and use React. Anyway.
Yeah. No, and those packages are super helpful as you're migrating from one to another because you can start going module by module as you're okay. So anyway, so the reason I wanted to talk a little bit about Meteor and React and Webpack, let me full screen this guy. Is because we found it very useful as we were building this kind of thing. So we started with just vanilla Meteor, so vanilla, just Meteor with Blaze and with Isobuild, so Meteor's build system. And we ran into a couple of difficulties. And so I want to mention obviously that all of these are being worked on, so it's not that Meteor is bad, it's just has focused maybe on some areas more than others. And so, in our case, some of these things were lacking. So the first one is that Meteor right now pulls everything together into one single JavaScript file. With the result that the initial download takes longer maybe than it has to, because when you're writing a big app, someone who just comes to your homepage first thing is they download your entire app, admin panel, everything there is. So it just takes longer than it needs to, and maybe if you're actually downloading maybe private stuff, admin pages, who knows, then maybe you don't even want public-facing stuff to have that kind of stuff. The second point is that, and I'm going to show you this later, client-side renders. So Meteor packs everything up into this one JavaScript file, sends you the one JavaScript file, and then in your browser, that JavaScript file calls a bunch of commands to actually render the page in your browser. With one of the drawbacks being that maybe in some cases it is not as fast, again, to render as it could be if Meteor sent you just a plain HTML page, as the case has been, for the last 20 years. That's been the normal status quo. One other thing that maybe was important to us is that search engine crawlers still aren't very great at dealing with those JavaScript pages. And so if you're doing search engine optimization, if you're concerned about your ranking in Google, that's maybe something you want to think about. Number 3 is that as long as you're, and this isn't entirely true anymore, but as long as you're just using Meteor, you're very much constrained within the Meteor ecosystem. And so at least for a long time, it was true that downloading packages from NPM, NPM mostly, but also other GitHub projects, whatever, was a little bit of a pain every time to incorporate those pieces of code into your Meteor project. And lastly, more of a kind of philosophical, architectural question, jQuery, in my opinion, doesn't encourage very clean coding. And React does. And so those last 2 issues React deals with pretty well. Those first 3 are a reason that a lot of people now are thinking about Webpack. So for those of you that weren't here for his talk, I wanted to quickly mention the difference between React and Blaze. So Blaze is the original system that ships with Meteor that you use to set up your pages and all the nice interactive JavaScript parts that then get rendered into your final page. So most of you have probably seen this. So you start with a template, give the template a name, and then that template with that name has a bunch of helpers. And those helper functions return values that get rendered into your page. And then you have, for that template, a bunch of events that I'm not showing right now, and those handle events, clicks, and so on. And Blaze is one of the big parts of Meteor that then pull all of this together into one magic JavaScript file that finally renders it in your browser. React is something that Facebook came up with a couple years ago, and that has been gaining popularity very rapidly. And in a way, it's a completely equivalent system. It reflects everything that Blaze can do. You can do in React as well. It just looks a little different. So yeah, it just looks a little different. You can look at the code right here, but at the end of the day, you have these files are called JSX files. You have this React script that then turns your JSX files into a big JavaScript chunk again, and that JavaScript chunk renders your page. And again, if there's any questions, please shout them out. And for the most part, there's very much a one-to-one mapping between your traditional Blaze template and a React template, which is called a React component. That's just the lingo. And so if you're ever migrating, it's actually not that hard. Whatever used to be helpers and events in your Blaze templates, you just make them arbitrary functions with arbitrary names in your component. A component is just one single JavaScript object. Okay. Instead of onCreated, onRendered, onDestroyed, they're called a little different. They're called component will mount, component did mount, component will unmount. And then there's, in React, you actually have a bunch of other ones that you can use for other moments in your component's life. And then instead of passing data down to your children components, in parent components, using, I think it was called instance data, I haven't done this in a long time, you use what in React is called props, and it's actually a very essential part of React. And instead of reactive vars, you use what's called component state. And so that handles essentially local template state or local component state. Any questions? Does this, do these things on the left-hand side sound familiar to people, or is this all like, okay. So the reason we switched to React, and now obviously reason number 0 is that it's it's no longer being maybe maintained as actively as it used to. But the main reason maybe was to get rid of jQuery, because jQuery encourages this style of coding where, oh, you have an event, oh, you know, in this event you want to modify something, so let's just use jQuery, grab that DOM node, do something to it, and then 2 days later you want to change your DOM node and you're like, oh, where did I actually modify this from? Where are all these events that may be acting upon this DOM node? And so it's much nicer to keep track of state, okay? So to have some sort of variables somewhere central, and you know that variable is responsible for that particular piece on your page, and everyone that wants to deal with that DOM node just deals with that one variable. Okay, so you kind of have this data flow that only goes in one direction. The second one is a practical reason. Obviously, switching to React means you now have access to all of the other React components that are out there. And I've used that quite heavily. So 3, again, server-side rendering. I mentioned this earlier. Normally you have your JavaScript file that gets downloaded, that renders it. It's actually nicer, at least in some situations, to render it on the server. Okay? And by rendering, I mean turn this JavaScript thing into an actual HTML string that starts with open bracket, HTML, and so on, and send that string down to the client to render directly. And finally, you enjoy thinner code because in Blaze it's 2 files per template, and in React it's just 1 file per component. So instead of me explaining this stuff to you, again, you should go back in September. We heard a wonderful talk at this meetup where this is all explained in more detail. The official docs aren't bad at this point, even though I actually prefer the official docs over the official tutorial. And if you're migrating, I found this to be super helpful, the meteorchef.com blog React versus Blaze. So that's a very nice overview over the nitty-gritty subtle differences between the two. Questions so far? No? Okay. Webpack. Has anyone switched to Webpack? One person. Has anyone heard of it or considered switching? Okay, a few. Okay, wonderful. So I don't actually know why this is showing up first. Oh, sorry. Okay, yes. So for those of you who are switching to React, things I wish someone had told me. So one of the things I found kind of different is that when you're doing Blaze, it's very tempting to have a helper, okay? And in that helper, you're like, oh, I need some sort of data from some piece of data from my database, and you just go collection.find1 and you just pull that in. You don't do that in React, at least not often. At least I found it to be unhelpful. What you do in React is you want to have one component that wraps everything on your page. Obviously, if you have multiple pages, it's pretty different stuff than you have multiple wrappers. But you have one wrapper, and then you have this React mix-in, and if you look at the docs, it'll become very clear. And then you just use this once. You pull in all the data you need, and you pass that data down to your children components as props. And you never actually, in your children, go and pull in more data. So that's one thing. Number 2 is that React doesn't really have a styling system. So everything is styled inline. So you're actually writing those HTML tags, and you go style equals, and then you put your style in there. Instead of nested classes, people use less, people use Sass, whatever you like to use. I was using less initially, okay? And I was kind of worried that switching to React, I wasn't be able to use those anymore, and I would have to really take all those styles and put them into individual components. Using Webpack makes that easy, and you can just keep your whatever style files you have. So that's very nice to know. And finally, yeah, really ES6 is super important. I found with React that was very important for me to really brush up on those things that make it much easier. Okay, so short mention of Isobuild in Webpack. So Isobuild is something that most people aren't even aware that is a thing. Isobuild is simply the name for Meteor's internal build system, meaning that collection of scripts that pulls all of your JavaScript and HTML together into one file. And both of them are from early 2012, so a few years old. So Isobuild isn't actually older than Webpack, or Webpack isn't actually more modern or anything, but Webpack focused on, unlike Isobuild, which was very much focused from the start on things like, oh, how can we turn this Meteor thing into a mobile app? You know, like how can we package all of this into, say, an APK for Android? Webpack was focused on how can we take this whole require and import system that you get in Node, and how can we use that for the browser? So maybe you've heard of Browserify. That's another one. So again, normally what happens in Meteor is that all your files are pulled together into one. Webpack lets you use require the same way you can in Node. And that has multiple benefits. The first one being that you have no more load order issues. So I've encountered multiple times that I had Meteor packages that monkey patch different parts of the actual internal Meteor stuff. Like, you know, Meteor collections, for example, were patched, Meteor published systems were patched, and so on. And if you don't load those in the correct order, packages assume things about Meteor that are no longer true because another package that was loaded before it modified things, and so on. And I had a bunch of troubles. And those are always a bit of a pain to handle manually. And if you're using components and packages in Webpack and you're just importing things, you get this big graph. And Webpack knows exactly which package is importing which one, and you don't have those load order issues. Number two, obviously, you can use any package from NPM, so you get this wonderful package JSON file, which you have in Node normally, and you just import any package you like. Number three, and this has been another thing that's been super important for me, is hot reload of components and style sheets. And so Meteor already kind of has that, so whenever you make a change, you'll have noticed that whenever you make a change to a code file, Meteor is watching those the entire time, and when you save it, Meteor reloads the page. Only that takes about, at least for me, because the project's relatively large, that takes about a minute, you know, not a minute, maybe 15 seconds every time. And 15 seconds is like just enough for your brain to go, oh, Facebook, Reddit, Twitter. And then 5 minutes later, like it's only 15 seconds, right? But 5 minutes later, like, what was I trying to do? And then you have to get back in your code. And so it really brings you out of the flow. And hot reload is this thing that only works with Webpack right now, that only reloads individual components of the page. And that happens most of the time within fractions of a second. So it's really useful. You know, if you have a typo somewhere, you change something, it's like, it's right. And lastly, another thing that's important, again, when you have a big project, is that you can split the parts of your code into independent chunks. So again, instead of having one big JavaScript file, you have multiple. And then Webpack puts all of your files into that very folder where normally Isobuild would put them. So it's this kind of cuckoo's egg thing where instead of Isobuild taking care of it, Webpack takes care of it, packages it all, and then gives it back to Meteor, and Meteor is like, oh, here are the files, wonderful, let's work. One thing I found very useful and I didn't find out about for quite a while, so I do want to recommend this to you, is that Webpack on GitHub has this analyze tool. So remember this. When you're actually building something with Webpack, you can have Webpack output this stats.json file. And then you can upload this into this wonderful website, which will then transform this stats file into, among other things, a graph, a dependency graph, okay, where you can see exactly what packages, what modules, chunks depend on which other chunks. And that really helps you figure out, okay, how can I organize my chunks, how can I make them smaller, what's making things inefficient, what's taking too long, and so on. Where do I get conflicts, where do I get redundancies? And so for our project, I went from one chunk with Isobuild to over 10 very quickly. And it's really made my life much easier. It's made the page load much faster. Yeah, highly recommended. So if you want to try this out, there are, to my knowledge, 2 boilerplate projects. So meaning projects you can just download from GitHub. They come with little sample apps. And then you just throw out that sample code, like you read the sample code, you figure out how it works, When you know how it works, you throw out the sample code and you put in your app, and it should just work. I've been going with the second one. Benoit Tremblay is a guy from Montreal. He's been very helpful in fixing bugs, so I do recommend this one. And obviously there are things wrong with it still. Because Webpack and Meteor is still kind of this new experimental thing, and there's a bunch of things that are still in flux. And if you do use this, you're probably going to have issues, and you'll see that there's already issues I'm working on with this guy. But don't let it discourage you. This is really fun, and it's working quite well. And so there's a whole ton of things I didn't mention because you would fall asleep. But if you do have questions, obviously email me. If you do have questions, if you do this, if you switch over, you do have questions, email me. My email address is over there. Yeah, or post them to the Meteor homepage. That's it. Thanks very much. It took a lot longer than I anticipated. Any questions? Yes.
So you have no more global variables in your code, in a Meteor code?
So you have a bunch. You obviously are still using Meteor, so there's still everything Meteor provides. So Meteor.whatever is still there. Accounts.whatever is still there.
But
you don't go out of your way to make your own, right? Like session variables you don't use, for example. And if you really, there's pros and cons to that, right? And if you want to get into the whole Facebook-style Flux architecture with a central store and a dispatcher, then sure, in a way you're going to have a global storage again, but you don't have to. Yeah.
We tried making a native app, like a Cordova app, with the Webpack yet?
No, I haven't.
We'll
Simply
do that.
because what we were doing is like so spreadsheet based, people there's just no point. No, I haven't.
Okay.
I know. I know there's people have been filing issues on that stuff, especially on the Webpack React Transform side. But yeah. Are you?
No.
No?
I'm a little bit scared of it.
Yeah. Okay. All right, no other questions?
Awesome.
That's it. So we are definitely looking for projects in terms of the original app I showed you. If there's anything you're like, oh, I could totally use this for XYZ, get in touch with me. Not ready for public release yet, but yeah, get in touch.